Hello everyone, welcome back to my channel. So in this video we are going to learn about conversion of any radix number to decimal, that is to decimal number, and second we are also going to see conversion of decimal number to any radix number. Okay, so both the conversions we'll see in this video. Okay, if you are first time to my channel, please consider subscribing and hit the bell icon to get more video notifications from my channel. Right, so conversion, we'll see the first conversion of any radix number to decimal. Okay, so this conversion, right, so the general form is given by n is equal to a n minus 1 r power n minus 1 plus a n minus 2 r power n minus 2 plus a n minus 3 r power n minus 3 plus so on, plus a1 r power 1 plus a naught r power 0 plus a minus 1 r power minus 1 plus a minus 2 r power minus 2 plus so on. Okay, so this is the number. So here n represents the number in decimal binary system, that is decimal number. Okay, r represents the radix to which we want to convert this number to decimal. Okay, so radix of the given number system. Okay, then n represents number of digits in integer part. So all these a n minus 1, a n minus 2, so on up to a1, a naught, a minus 1, a minus 2, all these represents the digits of given number system. So generally how can we write is, we take the number system like this. Okay, so at the center we will have the decimal point, so after that we will divide like this. So this is a minus 1. Okay, so this is a minus 2, a minus 3, and this is a naught, this is a1, this is a2, and so on. We can have the last number as a n minus 1, and then it is multiplied by r n minus 1, right? So from decimal we can start r power 0, r power 1, r power 2, so on up to r n minus 1. Similarly here also r minus 1, r minus 2, r minus 3, and so on. Okay, so we just have to multiply these two and add. Okay, so multiply these two and add with the other values. Okay, so let us take an example, then you will understand very clearly. Suppose 3102.12 base 4 is what in decimal. So we have to convert this radix of base 4, radix 4 decimal number system. We have to convert it into decimal number system. So if you write this in this form, so how can we write this? So we can write a decimal point here. So after decimal point you have only two numbers, 1 and 2. So before decimal we have 4 numbers. So this is 2, 0, 1, 3. So this is so r value is 4, so we can write now 4 power minus 1, 4 power minus 2. This is 4 power 0, 4 power 1, 4 power 2 and 4 power 3. Because here the total number of digits present is 4, so r power n minus 1 becomes r power 3. R is 4, so it becomes 4 power 3 here. Okay, so we just have to multiply this 3 into 4 power 3 and add with the others. So we have to multiply these two, 1 into 4 power 2, so multiply these two, plus 0 into 4 power 1 plus 2 into 4 power 0 plus 1 into 4 power minus 1 plus 2 into 4 power minus 2. Okay, so if you calculate this using your calci, you will get around 210.375 base 10. Okay, so this is how we can convert any radix number. So any radix number into its corresponding decimal. Okay, suppose if you want to have one more example, 1100.001 base 2. So what is this in binary? Sorry, in decimal. So given number system is a binary number system. So if you write this in this form, so it will be like this. So we'll have a decimal number. So after decimal we have three numbers, 0, 0, 1, and before we have four numbers, so 1, 1, 0. So this is 2 power 0, 2 power 1, 2 power 2, this is 2 power 3, this is 2 power minus 1, 2 power minus 2, 2 power minus 3. So the required decimal number n is given by, so even if you multiply with 0, there is no value here. So 0 into 2 power 1 is 0, 0 into 2 power 0 is 1. So I am taking only these values, 1 into 2 power 3 plus 1 into 2 power 2. Okay, on the integer part, and on the fractional part this also becomes 0, 0 into 2 power minus 1 becomes 0, 0 into 2 power minus 2 also becomes 0. So left over is 1 into 2 power minus 3, so 1 into 2 power minus 3. So if you calculate, you will get 12.125 in decimal. Okay, so you can follow the same procedure. This is the same procedure and this is the generalized form. So you can follow this procedure to convert any radix number into its corresponding decimal number. Okay, so next we'll see the next conversion, that is conversion of decimal number to any radix number. Okay, so conversion of decimal number to any radix, right? So in this conversion also decimal number, so we are given with a decimal number and you have to convert into given radix, right? So this again consists of two parts. One is integer part, okay, so second is fractional part. And the conversion has to be done like this. So for integer part, we have to make successive division with new radix r. So we have to make successive division with the new radix. So the radix which you want to convert it into, right, which we want to convert that decimal number into, so that radix I am taking it as r, so this radix I am taking it as r. So you have to make successive division with that new radix for integer part, and for fractional part we have to take successive multiplication with radix r, successive multiplication with radix r. So here you are getting these remainders, right? So when you are dividing, we will get remainders. So remainders must be taken in reverse order. This is very important, right? So for integer part you have to take it in reverse order. Similarly, the remainders after multiplication, remainders must be taken in order. So in the same order which you have got, you have to take in the same order for fractional part, and for integer part you have to take in reverse order. Okay, so just remember these points, then you can easily convert the decimal number into any given radix. Okay, so let us take an example, then you'll understand very clearly. So let us take a previous example only. 12.125 base 10 is what in binary. Okay, so previous example we have taken, so we have got something in binary, so we'll see whether we have got the same answer or not, whether we'll get the same answer or not. Okay, so this is real part, so 12 is the real part here, and the radix, new radix r is equal to 2. So successive division with new radix, so you have to divide successively. 2 6 are 12, so it is divided perfectly, so remainder is 0. So 2 3s are 6, perfectly divided, so remainder is 0. 2 1s are 2, and there is 1 remaining, so remainder is going to be 1. So you have to take in reverse order. So this is the order which you have got, so this is the order which you have got the remainders, but you have to take in reverse order now. So it will be equal to 1101. Similarly, for fractional part, 0.125, 0.125 is the fractional part, you have to multiply it with new radix 2, so it will be 0.25. so this will be the remainder, so 0, and the remaining things you have to take here. 0.25 is again multiplied by 2, so is equal to 0.50. so this is the resultant, so you have to write 0 here, and again take this 0.5 here, so into 2 it will be 1.0, so this will be 1. So even if you take 0.0, so it will be 0, 0 into 2 is again 0, so you can end here. So dot 001, this is base 2. So we have got the same result here also, right? So this is what we have taken and converted into corresponding decimal in the previous example. Now we have taken the same decimal number, we have converted it into corresponding binary, and we have got the same value. Okay, you can take another example. Suppose 658.825 base 10 is what in octal. So new radix is now octal, that is 8. So 658 is the integer part, you have to divide it by 8. 8 8 is 64, 8 2 is 16, so remainder is 2. Similarly 8 10s are 80, and remainder is 2. 8 10s are 80, 2 will be left over, so you have to take the remainder as 2. 8 1s are 8, and the remainder is again 2, and we have to take in reverse order, right? So we'll first find the fractional part as well. Is 0.825 multiplied by 8, so you'll get us as 6.6. so this 6 is the resultant, remainder you have to take here, and the remaining 0.6 is the remaining, so you have to take that into next step and multiply with 8, so you'll get 4.8. so resultant remainder is 4, and 0.8 multiplied by 8 again, so you'll get 6.4. so again 6, so 0.4. so you can continue, so I'll stop here, you can continue also, no problem, right? So you can continue, so you may get stopped like this, or if you have a repeated remainder you can stop there, or if you are writing some competitive exams, choose from the given option. If the option consists of 4 numbers after decimal point, then you have to again convert this into one more term, like 0.4 into 8 is 3.2, so you get 3 here. So if he has asked for 4 numbers, you have to continue up to 4 decimals like this. Okay, it is depending on option, depending on the given number also you may terminate. Okay, so you may terminate or you may not terminate like this, right? You can stop here. So the answer will be 1222.6463 base 8. Okay, so this is the answer, and this is how we can convert. Suppose if you want to take another example, 5386 base 10 is what in hexadecimal. Okay, so only integer part is given for this example. So 5386 you can divide with 16. So if you divide, you will get 336. Okay, 16 3s are 48. 48 again you will get 58, right? Again 58, 16 3s are 48 again, right? 106, 16 6 are 96. 106 means the remainder is 10. Again if you divide with 16, so 16 2s are 32, and 1 is left over, so 21. It is perfectly divisible, so remainder is 0. Next 16 1s are 16 and remainder is 5. So 10 in hexadecimal can be written as A, and we have to take the remainders in reverse order. So its corresponding hexadecimal number is 150A base 16. Okay, so this is how we can convert a decimal number into its any radix. Okay, so this radix may be of any value. Suppose if you want to take the previous example which we have taken for base 4, suppose 3102, it will be of very high value, I think. 3102. So 3102 base 4, sorry, 3102 base, it's okay, 3102 base 10. If you want to convert this into radix of 4, right? So how can we convert 3102? You have to divide it by 4. 4 7s are 28. 28, so 30 is left over, 4 7s are 28 again, right? And 22 is left over, 4 5s are 20, so remainder is 2. Again divided by 4, 4 1s are 4, so you'll get 37, 4 9s are 36, you'll get 15, 4 4s are 12, so remainder is 3. Again divided by 4, so 4 into 4, 16, 4 into 4 is 16, 34 you will get, so 4 8s are 32, 4 8s are 32, so remainder is 2. 4 12s, remainder is 0. 4 3s are, remainder is 0. So you have to take in reverse order, so you'll get 300232 base 4. Okay, so likewise you can convert any decimal number into corresponding any radix, right? So decimal number has to be converted into any radix. You have to follow these procedures. So for integer part, successive division method, and for fractional part, successive multiplication method. Okay.